Uh, okay, guys, thank you very much for coming. So today we'll be talking about topic here, BGP troubleshooting, especially with the specific here route origin. Okay, so BGP has attributes and has lots of parameters. Yeah, there are lots of parameters. Yes, and then one of them is route origin. And then we can use it to identify whether a route that is originated from BGP is actually incomplete or IGP or EGP. Okay. Right. So this is our agenda. Video review. Talking about BGP. And then this is our main topic. Yeah. Which is the attributes. Talking about the attributes and especially origin attributes. Okay, so we'll do this fast. We assume you already know some of them. Okay, so yeah, for the preparation or introduction, it's going to be fast. For those who are new, okay, we are GLC, Gadalintas Cakrawala. We are based in Bandung, Indonesia. We do training and IT consulting. And my name is Ahmad Mardiansyah. I'm based in Bandung. I'm a user of technology, several technologies like Linux, MikroTik, Ubiquiti, Python, PostgreSQL, what else? Bascript, yeah, many technologies. Okay, I'm a trainer, a MikroTik trainer, a consultant, and then if you have LinkedIn, and then we can connect here. This is my LinkedIn URL. Okay. Guys, if you have questions, and then yeah, you can do something. You can say something in the group chat, okay, or you can ask your microphone here. Our past experience, yeah, we do many things related to ISP, either build the ISP from ground up, so from 0 to something, okay, or we improve a current ISP with many several improvements like integration with billing or yeah, other solutions, because we also do programming, so we can customize solution for our clients. Details are in the website, okay, for our past projects. And then I can see here several people already joined. Thank you very much. Yeah, and I think, oops. Yeah, yeah, you can introduce yourself here. Yeah, at least we know where you're from. Okay, and then as a prerequisite, we assume you already know TCP/IP, MikroTik, routing protocol, and routed protocol. Okay, let's do some review. Yeah, as you know, we have a 7 OC layer for communications. Yeah, started from layer 1, 2, 3, 4, layer 5. Oops. Oh. Yeah, layer 5, 6, 7. Yeah, so BGP is using layer 3. Yeah, so it uses IP address, of course. And then on top of it, it uses a transport layer. And then based on that, it set up session between one router and others. Okay. And then we have an encapsulation process. So data from upper layer will be added by data from a header or information. So data is the one that you really sends, like your WhatsApp message, your email. The email content is the data, right? But it's not only the data that you type on your terminal, on your application. After you click send, and then the computer will automatically add more information so that the the message can arrive from source to destination. And then here we have a series of encapsulation, right? So we have data, and then this is layer 4. Either you use segment or datagram, and then packet, and then frame. This is your data, and then this is the header. We add another header, so we have 2 headers here. And then here we have 3 headers, plus the trailer, okay? And then as you can see, yeah, we have lots of encapsulation. So this is the data that you send on your WhatsApp. On layer 4, you add header, yeah. So one box here means one byte. Yeah, 1 byte equals to 8 bits. And then another header, okay, another header. This is a variation. This is if you use Ethernet. This is if you use Wi-Fi. So this is actually what you type, and then this is what actually the computer sends. Okay, so it's a big overhead. And then here's we have a router and routing. Router is the physical device. Routing is the process. Okay, and then here we have physical topology. Yeah, so usually when we design a network, we start from physical topology. So this one connect to that one physically. Yeah, so that's why it's called physical topology, right? But after that, in order for us to do the layer 3 planning or routing, we need topology, logical topology. Okay, so in logical topology, what we are focusing on is layer 3. So we don't know which layer 2 in the diagram. So in layer 3, way we do is it's like this. Okay, so this network connect to that network through this router. Yeah, so logical topology more on layer 3 information. Okay, that's the logical. Okay, we don't know which access point, we don't know. Okay, and then this is a routing table, how the routing table looks like. So package coming, and then the router will do routing lookup. So checking the entry here, whether it's match or not. Okay, checking here is match or no. Checking this the next prefix entry, sorry. Checking. If not, and then usually if no match, usually if the router has default route, and then we pick the default route for forwarding. Okay, so the default route actually is the last priority. Okay, the more specific, the higher the prefix. Yeah, so this is the longest prefix. Yeah, and then the longest prefix will be the higher priority, the most priority. Okay, this is one example. I think you already know that. This is the MikroTik where the routing table happens, routing table lookup happens. Yeah, so packets coming from here and then goes into the pre-routing, and then we have a routing decision, whether it decides whether you use you forward it or you input. Okay, if you forward it and then forward to post routing, and then goes to output interface. So in this one, out is this one. Is it possible that both are the same interface? Yes, it's possible. And then we know the concept of routing, how routing works, and then administrative distance. So for example, this is the gateway, right? And then here's your destination, and then here's your distance. Yeah, and then you translate it into a table. Yeah, so the gateway is this one. Okay, so the distance is this one. The destination is this one. And then here's the gateway over here. Okay, and then translate it into a routing table. So you have a field here for destination address, and then another field for gateway, right? And then another field here for distance. Okay. Yeah, so that's how routing table works, and then the distance. And then here's the administrative distance of routing entry that is originated from several routing protocols. So as you can see, if we use external BGP, administrative distance is 20. This is from Cisco, I think. If it is internal BGP, yeah, so it is 200. Yeah. If it is coming from RIP, it is 120. If it is coming from OSPF, it's 110. ISIS is 115. Okay. Yeah, and others. So that's the administrative distance, as you can see, showing the priority. Yeah. So the lower the number, the higher the priority. Yeah. So if you want to go from A to B, you are always picking the lowest distance, right? Yes. So that's the analogy of understanding the administrative distance. And then regarding the routing, we have a static routing and dynamic routing. Static routing means you have to log into each router here and then create the routing table. So this is the routing table, right? Okay, so this routing table, you create it manually, okay, one by one. Yeah, for 2 routers, okay, but 20 router, it's not funny. 200 routers, more not funny. Okay, so you create them like this. You log in, create, login here, create, login here, create. What happens if there is a change? You have to log in one by one. Well, in order to avoid that, we can do dynamic routing. Yeah, it's easier. So you just run. Yeah, you have to log in one by one, but you don't have to create the table manually because the routing protocol, yeah, either it's RIP or OSPF or BGP will be do it for you. Okay, so this table will be done by routing protocol. All right. Yeah, and then the next concept is asymmetric routing. Okay, so when in routing, what we can do is to we can only control the outgoing forwarding, outbound or outbound traffic. Okay, remember outbound. Okay, so it means that we are router 1, this is router 2, router 3. We can only control our outbound. Okay, so either to this way or that way. Okay. And then, for example, we choose to go to router number 3. Okay, so the connection will be like this. Okay, but for inbound, that's up to the routers decide that. And then the other router says that, okay, if I want to go this way, and then here's the path. Okay, so going this way, yeah, inbound this way. Is it possible? Yeah, that's how it works. Okay, next is the BGP, our menu today. So BGP is dynamic protocol. It's path vector. It's different to OSPF. OSPF is a link state. It's a connecting AS number. So if you use BGP and then you don't have AS number, how come? Yeah. So in order to set up BGP, you need to have AS number. Okay. So every router, you need to create BGP peer. Okay. And then we will only receive and send routing prefix, see routing prefix to the peer. Okay, so how routing prefix looks like? Yeah, this is routing prefix. Yeah, so this is prefix, prefix, prefix. Yeah, so those prefix are exchanged between routers. So I receive some prefix and then the other will receive a prefix from me. Okay, that's how it works. And yeah, BGP works on layer 5. Is used for session, to set up session layer. Yeah. And on layer 4, it uses TCP port 179. So it is different compared to OSPF. OSPF do not use TCP. OSPF is just using a multicast address. So there is no layer 4 involved in OSPF. I mean, OSPF routing protocol, okay? So yeah, up to layer 3, yeah, which is, and then the layer 3 is multicast, okay, either .6 or .5, okay, 224.0.0.5, 224.224.0.0.6. Okay, so those are the IP address used by OSPF. But now we don't talk about the OSPF. We are talking about BGP, right? So BGP here is used by. Is it recording? Oh yeah, sorry. Used by all routers in the internet, yes. And then the route contains a full route, yeah. So all prefix in the internet, okay. Yeah, you have to separate between IPv6 BGP and then IPv4 BGP. And then here's the partial route, yeah, specific prefix. And then actually there's one here, default route, yeah, default route, 0.0.0.0/0, right? Yeah, that can be option for BGP, yeah. But default route has always lowest priority because the length of the prefix here. Several consideration, yeah, it's more knowledge, yeah, to operate. Yeah, in order to understand BGP, you need to understand how BGP works. Okay. Is the audio correct? Yeah. More complex, yes, compared to RIP. RIP is very simple. You start and then, yeah, you just leave it out. And then they will talk to each other and then they will exchange the routing table. Okay, so AS number. Yeah, so this is how the AS number looks like. Yeah, so AS number is collections of routers and networks. Okay, so two things, routers and networks. So you need to have a block of IP address, of public IP address. So for example, 114, let's say 0.1.0/23, for example. Yeah, so this is your network. Okay, so this network belongs to this AS number. So you will announce that prefix here to this router, and then you have two. Okay, so same thing. Okay, same prefix goes to other peer. Okay, so you're announcing your prefix here to your peer. Okay, so inside, for example, your AS4, yeah. So you need to have AS number. So it's a collection of. Okay, let's go back. You have routers and the networks under one administration. Yeah, so under one organization. Okay, the AS number is given by IANA. Okay, via RIR, registry regional. Either you have APNIC. I'm in Asia Pacific, so I must use APNIC. If you are Latin America, and then LACNIC is the AFRINIC, is the ARIN. This is for Africa. This is for North America. Sorry. And then here's the Europe. Okay, European use this one. And then inside AS, so inside AS, so here, this one, here. We run IGP, okay, interior gateway protocol, either it's RIP, OSPF, ISIS, EIGRP. So on this particular routers, you run two, what is it? Two routing protocol, yes, correct. So on border router, yeah, so you run two types, either you run IGP and then you run BGP. Okay, so IGP, BGP. Okay, so you run two routing protocol here because this is the border router. Okay, same thing here. For this one, you don't have to use BGP. Yeah. So you just run IRGRP. Sorry, IGP, sorry. And one of the IGP is IGRP. Okay, so how BGP works, as I said, is very simple. You need to create router ID as number, create a BGP peer, okay, and then set up a routing filter, either it's inbound or outbound, okay, and then exchange routing table, and then the router keeps sending keep alive message periodically, so to make sure that the peer is up. And then here's the path selection. So when you receive prefix, you will have more than one peer, for example, and then you will calculate the best path. Okay, and then here is the algorithm. Okay, so first is, ignoring the route is not valid. Yeah, like an X hop is reachable, AS path is received, and then not rejected by routing filter. Yeah. And then here's the path. The first priority is best path, yeah, the lowest path. And next is the weight. Okay, but weight is only for local. Next consideration is local preference. Okay, and then here's the AS path. Sorry, so this is the first path received, automatically consider best path. Yeah. If further received part will be compared to the which one is better. Okay, so this is the first path received. Yeah. Okay, so this is the algorithm in MikroTik. Yeah. So again, first is the weight, and then local preference, and then AS path, and then locally originated via aggregate or BGP network. Yes. And then here's the origin. Yeah, so this is our topic. So either it's coming from IGP, okay, IGP interior gateway protocol, either it's RIP or whatever. Is it coming from EGP, okay, exterior gateway protocol? So previously, before BGP, we have this EGP. Yeah, EGP is lower, and then incomplete. Yeah, so here's the algorithm. So IGP must be higher. Okay. And then we have MED, and then prefer eBGP than iBGP. So as you can see, this is only obvious. So EGP is 20 for distance, IGP is 200. So 10 times lower in terms of distance. Okay, so let's do. So this is our topology. Yeah, so I will log in to router 1 and router 2, and then we set up a BGP connectivity here. Okay, so we set up a peer, and then we will set up routing filter. Yeah, and then we'll check. We'll see the routing tables. Yeah, between them. Okay. Let's continue. So this is how origin looks like. Okay, so it's over here. So it's coming from incomplete. Why? Usually it's coming from static route. Okay. IGP is from, for example, OSPF or whatever. All right. So yeah, I think that's all. If you have questions, and then please write something in the group chat. If you're interested, just come to our training. This is end of slides. Yeah. For feedback here, you can click this link. I will post it on the group chat. Yeah, slide will be available on Slideshare. And then Discord is available in Bahasa Indonesia. Recording will be available on YouTube. Okay, so now I will share a whole screen here so that you can see what's going on there. Okay, let's check. Perhaps this one. Okay, so I will change it. Oops. I'll change this one to topology. Okay, so I'm here at router 1. Yeah, this is router 1, okay. And then here's the router 2. Yeah, here it is. Okay, so what do we got? Okay, let's say, yeah, so router 1 and router 2, we have IP address. So this is the IP address. And then we have a loopback address here as well. IP address. Okay, so we will set up. We will use here you can see. So we are using Ether 3 to connect between these two routers. Okay. Okay, so Ether 3 is this one. Ether 3 is this one. Okay, so let's do that. First, we set up the filter. BGP out. Okay, and then we set up the filter first. Okay, so we use if DST in. So we just accept everything. 0 and destination length in 0/24, right? And then here we put action accept. Okay, so simple as that. And then we can copy this BGP in. Yeah, simple as that. So okay, so this is OSPF. Okay, so here we need to set up a connection. So we say peer router 2. Okay, so we don't have our template. So this is our AS1, for example, or router ID 0001. Okay, remote address is 11 1.2.2, right? Okay, remote port standards is router 2. Okay. Yeah, so as you can see, we are connecting to router 2. So this is router 2. Yeah. From here to here. The router ID is local. Yeah, remote address is this one here. Yeah, connected via R1 Ether 3. Okay, should be okay. Oh yeah, here is the AFI, yeah, address family. We want to exchange route IPv4. Yeah, IPv4. Here at standard, we don't have to use it. Next hop choice. Yeah, and then I think okay, yeah. Okay, so this is input filter and this is output filter. Okay. And then for the network that we want to advertise is we can set up it here. We can set address list, BGP network. BGP out, yeah. So it's 10.0.0.1. We want to advertise our loopback address. Okay. Put them here. Oh, not there. IP firewall. Yeah, BGP out. Oh, local role, eBGP. Yeah. Okay, just use this one. And then, yeah, it says session is not connected yet. And then same thing also needs to be done here. So peer router 1, AAS1, sorry, IMS2, connect via, we want to set up IPv4 BGP. My router ID is 10.0.0.2. Okay, remote address 7.1.2.1. Remote AS is 1. Okay, let's do the comparison. Yeah. Okay, so this is eBGP. Yeah, looks good. Our local address. Yeah. Here we are missing one here. Role. Okay. Copy it from here. BGP end. Okay, meaning we accept everything. Okay, incoming, inbound. Okay, and then we set up outbound, same thing. And then on this peer, we we set up the input filter and output filter. For output network, we can check here in firewall, address list, BGP out. BGP, how can BGP? Just put it out. 10.0.0.2. Okay, so both are okay. Is it correct? Yeah, hopefully. Okay, router ID is here. Yeah, should be okay. Wait. Now. Yeah, here, as you can see. So we have done the BGP, and then we can see slash routing BGP session. Oops. So BGP advertisement print. Oh, okay. So it means that I'm not advertising anything. Okay, so let's check. Yeah, let me check again. Okay, I'm troubleshooting here. Seems like it's not okay. Oh, okay, let me change the address. BGP network. BGP prefix. Yeah, I changed the name, yes, so it will not be confused by you. BGP prefix, right? Oh, sorry. I misclick. Oh, yeah. This one I think is wrong. Yeah, typo mistake. Very bad. Yeah, the name is BGP prefix. Firewall BGP prefix. Okay. BGP in, BGP out, BGP prefix. Yeah. Okay, let's check in the okay, so as you can see, session is established. So this is it means that the session is already done. So it was because typo mistake. Yeah, very yeah not very simple but deadly. So as you can see, this is remote to the router 2. Okay, so remote address, remote. So sorry. We can check as well the advertisement. Yeah, okay, it's there. So as you can see, this is the settings. Yeah. Oh, I need to change here as well. Better if I change instead of BGP out, I put BGP prefix. Okay. And then 11.1.2.0/24. Yeah. Am I? Okay, I have that one. Okay, I'm checking the BGP print. Yeah, so I'm announcing two addresses. This one and this one. Okay. So now something. Oh, no reply. Yeah, okay. All right, so as you can see, okay, so let's discuss the peer. Yeah. So remote, yeah. So this is the, okay, let me check again. Okay, so this is the session telling the session of a remote address. Okay. So it is telling the session of this one, BGP peer, this one, which is this router over here. Okay. So here's the remote address. This is the remote AS number. And then this is the capability that we are using. So we are using IPv4 BGP. Is it possible to use both? Yeah, yeah. Remote ID, yeah. And then this remote capability, blah, 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 blah. And then that's it. Okay, so this is the local, yeah, local settings, okay, configuration. Here's the attributes, here's the filter, yeah. So this is important. So this parameter is located at the filter tab when you create the BGP. Okay. And then here's the statistics. Yeah. So right now, what we are doing here is to set up eBGP peer. E means external. Okay, so through this peer router 1, in this case is over here. Yeah, so we are not on that tab. Or perhaps you can change it. Yeah, so peer 1. So peer 1 here. Yes. All right, so that's the information regarding the BGP. And then, yeah, what we are looking is the prefix that is shared by the BGP, right? So we can go to BGP here. I'm sorry, routing, IP routes, and then you can see there are some, for example, here. Okay, so this route is from BGP, or you can filter here. Yes, BGP is yes. Okay, you put a filter, so it means that you only display a prefix that is received by the BGP. Okay, and then as you can see, status here, origin is IGP. Okay. Is it possible to you see others prefix? Yes, yes, it's possible. Yeah. So, or you can show columns. Where is it? Here's the origin. Yeah, origin. Yeah, is it possible to see other than IGP? Yeah. I think we can do. Yeah, redistribute, for example. Try this one. That's on IGP. And then you can do static. Yeah, if we have a static route and then we want to share it through BGP, yeah, it's possible. But currently, it looks like I don't have any static routes here. Let me check. Oh, perhaps this one. Yeah. Yeah, so as you can see, origin is still IGP, but okay, so I'd like to share that one. Routing filter, BGP out. Yes, all of them are out. Okay, so that includes BGP and IP firewall. And for example, we can add prefix to go to 5555, for example. Yeah, so here you can see that static routes is also redistributed by BGP, and then the origin is IGP. Well, I'm still wondering whether we can reproduce the incomplete here. Okay, let me check again the BGP. Usually the redistribution here Should be okay. Yeah, okay, so let's see. Yeah, usually, so as you can see, I'm redistribute my own OSPF, right? So that's why you can see many entries here. If I turn it off, then you will see nothing. Okay, so this one here, default originate, is distributed as well. Okay. Yeah, so what I'm doing now is trying to reproduce this, to distribute this one as incomplete. So like what I'm doing here. Forgot the way. Yeah, usually incomplete means it's not part of the BGP. Okay, but it is already there. Okay, let me check once again. Okay. IP firewall. Let's say I'm announcing 0/24. Okay. Okay. And then session is established. Router 2. Usually incomplete happens when you announce the prefix. Maybe this one. It's already there. Okay, perhaps I think I will do that later. Sorry for that, guys. Yeah, so the thing here that I want to show you is I just want to show you that there is a parameters called origin here. Okay, so this is the thing that you need to be aware of, where the prefix coming from. Okay, if it is IGP and then it's Internet Gateway protocol. Okay, or incomplete. So I have one router here which I cannot show it to you using incomplete, but I cannot display it for you because it's private information. So perhaps you can turn it off, the filter. Yeah, and then as you can see, we have several redundant destination. Yeah, as you can see. Yeah, so we have routes to 10.0.0.1. There's also 10.0.0.1, but this one is preferred. Why? Because of the distance. Okay, so the distance here is 110. This one is 20, so this one is more preferred. So this one, as you can see, is coming from O. O means OSPF. So this router is running two routing protocol at the same time. Right, so I think that's all. Yeah, sorry for the delay. And then yeah, need to find out to perhaps in the future. Yeah. I can find out the way to display. Okay, so yeah, I got a message from admin for a photo session. Please, if you don't mind, please turn on your camera, and then we'll take a photo session here. So I think I need to stop the screen share, I believe. Yeah. Oh, yeah. Right. So hope you guys enjoy the webinar. Hopefully I'm using my new microphone here, so hopefully it's good. I just bought it today. Well, okay, let's take a picture. Okay, 1, 2, 3. Okay, one more, 1, 2, and 3. Yes. Okay, there's a new faces here. Right, guys, thank you very much. See you in the next webinar. So I believe in the future we're still discussing routing protocols. Yeah, because yeah, I'm doing several projects here, very busy at the moment, and then most of the problems are related to routing. So perhaps it can be a good case study for us. All right, thank you very much, and then see you in the next webinar. Yeah, thank you. Have a nice day.
Thank you.